Hi, broadcasting from California and from Paris, a conversation about transformation. So let's get started. Transformation, it's a pretty big word, and it thus generates emotions, extreme sometimes, like excitement, or maybe for some people, some fear as well. In any case, what we do know is that industry transformation is a all-encompassing journey. You have to change your methods. You have to put in place new tools. Teams have to be trained. Sometimes teams have to be replaced. And in all cases, it's about breaking silos. So a few years ago at the Paris Air Show, Safran described their journey through transformation. And they spoke about the magnitude of the change. They started out by saying that in a normal cadence of bringing an airplane to market, which was roughly 5 years, they needed to shave 18 months to come to fewer than 4 years. And that type of time compression had never been experienced before. Did they succeed? Yes. And they did so with what might seem like an obvious approach. They turned tasks that used to be sequential into synchronous, so that actors who were used to being upstream or downstream from each other were now actually in collaboration much earlier in the timeline that they were habituated to. And they did so by bringing people into a virtual prototype. And what's remarkable is the diversity of the actors who were involved in making decisions virtually. It was the people who worked the assembly line, of course, the engineers who designed the assets and designed the assembly lines, HR, management. The decision-making, the synchronous decision-making was made possible because of the right people being in the right room, making the right decision at the right time. So it might sound simple, that my children might even say, well, that's obvious. But of course, we all know that to be able to change your rituals of decision-making, to enter this synchronous world, requires a trust in the decision-making environment, a trust in the models that you're using that is fundamental. Which is why oftentimes when we talk about transformation, people use the adjective complex. So today's conversation is about changing our mind frame. Instead of using the word complex, we would like to invite you to use the term richness. And for this conversation, I've invited Dr. Francesco Chinesta, also known as Paco, who requires really no introduction, but let me say briefly that he is professor at Arts et Métiers Paris Institute of Technology. He's professor of computation. He's a world-renowned researcher in simulation, computation, modeling. And we have the great fortune of having him as our scientific director here at ESI Group. So let's start with a question for Paco. You introduced the term richness inside of our organization. So can you please tell us why this is an important mind shift?
Thank you very much, Cristel, and good morning, everybody. So Elon Musk said, engineering is magic, but magicians said, magic from outside, technical from inside. So this is the art of engineering. Engineering is the ability of replicating the reality in order with the just richness, in order to take the right decision just in time. So finally, engineering is a matter of richness and efficiency. It's not a matter of simplicity or complexity. So obviously, the just richness, not less, but not too much, because you know very well that the excess, like the defect, are not the best partners. Take the just decision with the just accuracy. The accuracy also depends on the application. Sometimes 10% accuracy is enough. Sometimes 0.1% of accuracy is not enough. So it depends on the application. And just in time, just in time to take the right decision. And sometimes we have minutes, sometimes we need to take a decisions in milliseconds. So this is engineering. It is combining the right richness in order to obtain the just prediction just in time, a matter of richness and efficiency. And sometimes when we are addressing very large system or systems that include a lot of uncertainty, finally in these systems, we can propose a model, we can obtain the solutions very, very fast, but sometimes the solutions are not good enough. And in those cases, ESI proposed a few years ago a new concept of hybrid engineering. This means when you obtain a prediction that is not in perfect agreement with the reality, you take note, you don't panic. We create a model of the gap. And this was a proof of concept that we developed recently with Dassault Aviation in order to prove this ability of the hybrid paradigm.
So let's just take a step back and make sure our audience understands what was the challenge that Dassault Aviation sought to resolve. Well, fundamentally, it's about extending the lifespan of the aircraft, and that requires optimal maintenance routines, and that in turn requires optimal choice of flight and trajectories. So you can imagine that starting with this initial variable, optimal choice of flight and trajectories, the combinations are infinite, or at least it seems that way, all the range of choices. So Paco, can you let us know if that's even possible?
Obviously, it's possible, and it's a very simple equation. Finally, we establish in our hybrid twin, in our hybrid paradigm of engineering, that when you combine a knowledge-based model that is based on physics in general, and when this model provides a prediction that is not totally in agreement with the measurements, you take this deviation, you apply artificial intelligence, and you can create your model of the deviation, the model of the gap that we call usually at ESI the model of the ignorance. And as soon as you obtain the model of the ignorance, now you agree with me. If we take a model that provides a prediction, and we add the prediction of the deviation, when you put prediction plus the prediction of the deviation, this is equal to the physical reality. As we prove in this case with Dassault Aviation, that by combining this nominal model with the model of the gap, we obtain almost perfect predictions in real time, in the time to take the decisions in this application.
So just to repeat, because this is the crux of today's conversation, nominal model plus model of the gap, that's the flight of Dassault Aviation. Thank you. This also illustrates what we were meaning by richness, right? Because the entire richness, the knowledge base, the nominal model was leveraged and augmented with the missing piece in order to become the aid in decision making that's required for business model considerations, right? So this is ESI's approach, and it is perfectly adapted to the magnitude of challenges that we're seeing across numerous industries. Let's take another example, ground transportation and automotive. So we know that we're all living through, certainly in our lifetimes, the most significant transformation of the automotive industry, possibly a centennial transformation, once in a century. And the challenges are fabulous, right? So new energies, lighter vehicles, safer vehicles, and Renault is our next keynote speaker. So you'll have the opportunity to hear straight from them how they're tackling this. But let's take another example. Their partner Nissan has set a very ambitious carbon emissions goal, and that requires producing much lighter vehicles, which means much lighter parts, which means different materials. And so they embarked on a journey to figure out how to leverage carbon fiber as their alternative material. And it meets the lightweight criteria, yet in their first iterations, it was taking them 2 hours to produce a part. And thanks to ESI solutions, thanks to bringing the right richness at the right time, right, leveraging the simulation environment, they were able to reduce that 2-hour cycle to 2 minutes. That is a 100-fold practically improvement. So this is what motivates us at ESI, right? This is our vision and our mission. What's our vision? We envision a world where industry can commit to bold outcomes, addressing high-stakes concerns, such as environmental impact, safety and comfort for workers and for consumers, and adaptable and sustainable business models. That's what motivates us. Within that, how do we contribute? It's our mission. We provide reliable and customized solutions anchored on predictive physics to allow industry to take the right decision at the right time. Now, how are we organized at ESI in order to deliver that, right? How does ESI actually deliver on this mission? Well, it's a handful of key ingredients. It starts with our solutions, combinations of software and services anchored on predictive physics and developed over nearly 5 decades. And they're not developed in abstraction or in a silo. They are developed in co-creation, being pulled by the requirements of global industry leaders across 4 focus industries: aeronautics and defense, automotive and ground transportation, heavy industry, and energy. And it's important that we've developed our applicative knowledge across these industries because that is one of the sources of richness. It's the ability to translate and transfer breakthroughs from one industry to the next. Just a few days ago, Vincent Champagne, who is the Chief Digital Officer of Framatome, a key international nuclear player, was talking about the progress in safety and that required significant improvements in the knowledge and the practice of welding in nuclear. And that same knowledge was transferred to the automotive industry, to the aeronautics industry, to create order of magnitude progress in the safety in those industries. And now we're in a virtuous cycle of cross-industry fertilization, where the progress from one industry on this very specific topic of welding is benefiting the other industries. And ESI is at the heart of that cross-fertilization. Through our applicative knowledge enables, by analogy, other industries to accelerate their transformation. The last ingredient is a committed company. We signed the United Nations Global Compact about 3 years ago, and we are completely committed to standards of corporate social responsibility. And so it's my great pleasure to inaugurate today our corporate purpose. Our corporate purpose is to boost human creativity to drive industrial performance to ever higher levels. This emphasis on human creativity has always been at the heart of ESI, and it will continue for the future. And it's this culture that enables us to continue to attract remarkable talent globally inside of our walls, right, inside of ESI, but of course, among our customers and partners. And so it's with great pleasure that I thank the individuals who contribute to ESI Live today, our keynote speakers, our industry speakers, and of course, all of the ESI personnel who produced this event. Thank you very much.